Hello everybody. Welcome to the second video in the TypeScript Engine tutorial series. The first video of this series was sort of aimed at a lot of initial setup and getting things ready to actually build our game. And so, just to sort of recap where we left off, I'm going to go ahead and run what we have so far. And so we have some a basic game loop that is just updating the title, and that's it. It doesn't really do anything too fancy. It's very basic, but we do have a game loop in place. So what we're going to do now is actually initialize WebGL. And what WebGL is it's a graphics API. And it's an interface that allows programmers to initialize the graphics hardware on the client machine through the browser. And it's based off of something called OpenGL, which you may have heard of. And WebGL is a sort of lightweight version of that. It's compatible with a lot of devices, specifically mobile phones, and it's really becoming quickly a very common platform to develop games on. And so it works through the canvas element in HTML5, and so those are the things that we're actually going to build off of. And the goal of this video is to initialize WebGL and get a game loop rendering to a canvas element on the screen. So that's what we're going to go ahead and do. But before we get started with that, let's go ahead and do a couple of house cleaning items. So right now, everything that we have is in our app.ts TypeScript file. So we've got our window onload event, which basically bootstraps our engine and then launches everything from there. And what I like to do out of good habit is I like to keep my classes to about one class per file. There are some exceptions to that, but it's a good practice because that way you don't wind up with files containing tons of classes, and it makes things really easy to find because you know by the name of the file what is contained in that file. And so right here we actually have our engine class contained in our app.ts file, which is not really where it belongs. This file should be really simple and straightforward. All it is basically just our bootstrapper. So we're actually going to move this to a new file. So let's go ahead and right click our TS engine project, and we'll go ahead and add a new TypeScript file. We're going to call this engine. And from app.ts, we're actually going to copy this whole section of code here. Actually, we're going to cut it and paste it in engine.ts. And the other thing that is good practice to do is to always comment your code. Now, I haven't done this. I'm not going to do too much of this on screen, but I want to do it enough to sort of show you why it's a good idea. First off, when you are programming and you have your IntelliSense comes up, which is what happens when you type this dot, you get these individual pop-ups here, and there's nothing really here that tells you what it is. Maybe the method name tells you what it is, and that should definitely be descriptive, but if we added some comments to that method as to what it does, it would make things a lot clearer. So Visual Studio makes real good use of the standard JS doc style of comments. So comments in JavaScript can either start with a / like that for one line, or a /* for a multi-line comment. So as you can see here, this comment spans multi lines. This code doesn't get executed. So anything you can type free-form text in here, and anything that's entered in there does not get compiled or run. And so this multi-line comment starts off with /* and ends with */, and everything in between that's a comment. So what JS doc style commenting is, or JavaScript doc style commenting is it provides a very specific format of comments that Visual Studio is aware of and can pick up on to add to the IntelliSense information. So the way that you kick that off is if you type /*, and you'll note that it actually inserts a closing comment character sequence there. And so this allows us to very quickly scaffold some comments in our code. So what I want to do here is just say the main game loop. And now in our IntelliSense, if I type this.loop, you can see the main game loop shows up here. You also get that if you hover over the method of, or already typed code. So it's a real handy way to sort of know what's going on in all your methods. Now, general rule of thumb is classes should be commented and public or protected members should be commented. I don't typically comment private classes, only because private classes are only concerned or only ever accessed by the class that contains them, and there's not really a need to ever go back to that once you're finished with a private method. So I typically don't comment private methods or private member variables. So what I'm going to go ahead and do is I'm just going to enter in some comments here. So the main game engine class and the constructor here, which doesn't actually do anything at the moment, creates a new engine and starts up this engine. So it's a little more clear externally what's going on. So if we go back to our app.ts, we can actually see here creates a new engine. So it's just a way to sort of neatly document in your code what's going on. And it's very good practice to always do this. The other thing I'm going to do is I'm just going to say the main entry point to the application, because this is the main thing that gets run first. And the other thing I'm going to do is go ahead and get rid of this document.body.innerHTML. We don't need that anymore. And I'm going to name this variable something a little bit more meaningful. I'm going to call it engine. Just rename this here. And for now, we're done there. So we're probably going to eventually be adding more stuff to this, but for now, I'm satisfied with that. The other thing I want to do is go into our index.html and get rid of this some text that's there. And for right now, I'm actually going to leave this body blank. And I'll sort of go into my reasons for that now. So what do we do to actually get a canvas element? So one way that we could create a canvas element actually is to say canvas, like this. And that would give us a canvas to render to. So if I actually run this, we still have this here for some reason. I've apparently forgotten to remove that, so I need to get that out of there. But if we go into the element inspector here in the browser, we see that we have a canvas, and it defaults to 300 by 150 as far as its size go. But if we look here, we actually see our canvas element. So that's one way of adding a canvas. If we go into the... Let me just delete that. If we go into the engine, first off, let's go ahead and... Oh, that's weird. Why did that still append that text? Okay, so this brings up actually a good point. So you'll notice that the foo text was still there beforehand, and I hit a couple keys on my keyboard, and it went away. So what happens with JavaScript a lot of times is it winds up being cached. And what that means is, in order to sort of save internet bandwidth, it keeps a copy of the JavaScript file locally and just references that. And if the JavaScript file changes, the web browser might not always know that. So one thing that you might need to do is what's called a force refresh, which means that everything that is pulled from the website is pulled fresh from the website. It doesn't use a cached copy. So the way that I always do this is instead of hitting F5 for refresh, I hit Control F5, and that actually gives me a clean copy. So I just wanted to put that out there. So anyways, now we have our canvas element gone, and the next thing that we need to do is actually create one in code. And the reason that I like to do that is because we're going to need a reference to it anyways, so we might as well go ahead and just create it while we're in here. So to do this, I'm actually going to create a new class. So I want to add a new TypeScript file, and we're going to call it GL. Very simple. That's for WebGL, short for WebGL. And the other thing that we're going to do is we're going to put namespace TSE to match up with what we had before. And we're going to export a class called GL Utilities. Okay, so the next thing that we don't want to do is we want a var called GL, and we want to export that so that it's globally accessible. And that is of type WebGL rendering context. There we go. So what this is this is actually our entry point into WebGL. And we want that to be globally accessible. So we export a var, or global var, called GL. Nice and simple to access. The next thing that we want to do is we actually want to create a initialize method inside this GL utilities class. So it's going to be a public static initialize. And we're going to have a return type of void. Okay, so let me explain the static keyword. So if you remember with our engine, we have this start method here, and we have our constructor. And on the app.ts, we create a new instance of the engine. And then from that instance, we call the start method. So that is what is known as a member function or method. The terms function and method, by the way, are sort of interchangeable as far as TypeScript goes, but so if you hear me say function or method, they both mean the same thing. So what a static method is this method does not require an instance of GL utilities in order to be executed. It's simply called by saying GL utilities.initialize. And you could tell this from the IntelliSense. So if I go in here to the engine class, and in start, I type GL utilities dot, you'll note that I have an initialize here, and that's our initialize method. So I'm able to call this just by referencing the class name and saying initialize. I don't have to create an instance of it. So that's the difference between a static class or a static member variable and a typical instance member variable. Such as or function such as start. So back here in GL utilities, the other thing that I want to do is pass a optional property called if I can spell, element ID, and that's going to be of type string. And to make it optional, we put a question mark there. And so what that means is if we call this method without passing anything to it, it will use undefined for this value here. So, so in our engine TS, you'll note that we're not passing anything here. And it does show up as having an optional property. Now if I were to get rid of the question mark, just to sort of show, you'll note that this is now throwing an error saying expected 1 arguments but got 0, because it's actually expecting us to pass a string here. And so what we're going to do is we're going to allow the user to either pass a string or not. And what that's going to be is the element ID of the canvas element that we want to use. So if we were to create our canvas element here, we would assign an ID to that, say like this. We just set its ID property to something. And in our engine, we would pass a string called something. And then this code would pick that up and know to use that specific canvas element by its ID. But we're not going to do that. So, what I'm going to do here is I'm going to say if element ID is not equal to undefined. And for those of you who are familiar with C++ or C#, you'll note that this expression seems a little bit weird. And I'm not going to go into depth about this, but this is typically what you'll see in C++ or Java or C# or any of those kind of languages, is something that looks like this. So the exclamation point means not and then equal. So this is saying not equal. If we wanted to check for equality, we would say equal equal, and that's a check for equality. But in JavaScript and therefore TypeScript, this isn't always quite enough, because there are situations where some values can equal other values that you might not necessarily think would be equal. Okay, so the difference is double equals does an equality check to say if one side is equal to the other. Triple equals does a equality check and a type check to make sure that they're the same type. And TypeScript actually saves you from a lot of these issues, because JavaScript you can compare a zero string to a numeric, and that will actually wind up being true in JavaScript. In TypeScript, it actually doesn't allow this, but it doesn't save you from all things. So one of the most commonly known ones is if null equals undefined. And most languages don't have an undefined and a null, but JavaScript does. So the difference here is undefined is every single variable that's ever created in JavaScript that's unassigned is considered undefined. This is the default value for every type of value in JavaScript, whereas null is actually an object. And I don't really want to get too deep into this here, but to sort of prove this equality theory here, I'm going to go to the browser, and I'm going to hit F12 to bring up my development tools, and I'm going to paste this check into here. So we have null double equals undefined. And that equates to true, even though they're two separate types. However, if I paste this in here and put a third check in here, so we now have null triple equals undefined, that comes up as false. So this can actually wind up getting you into trouble if you're not really careful with it. And so as a matter of good practice, it's always a good idea to use triple equals and triple not equals for everything, just so that you never have this sort of problem. The other thing I should mention about null is, by default, nothing will ever be assigned to null. That must be done programmatically. So if you ever see that something is set to null, that was done explicitly by the code that you've written, not just by not having been assigned a value. So enough about that. So back to the topic at hand here. We have element ID triple equals undefined. Whoops, that needs to be not equal undefined. And so what we're going to say is if element ID has been passed, then what we're going to do is we are going to use the element which has an ID of that which was passed. So what I'm actually going to do here is, before this line, I'm actually going to create a canvas variable. So I'll say let canvas, and that's going to be of type HTML canvas element. And so this is undefined by default. And so what we're going to say here is if our element ID is not undefined, we are going to say canvas. Why isn't that coming up? Because I spelled it wrong. So if our element ID is undefined, we are going to assign canvas a value by calling document.getElementById. And what this does is it scrubs the web page that this is being executed from for an element that contains an ID that is passed here as a string. So we could say SDF. If we have an ID on the page or if we have an element on the page that has an ID of SDF, that's what's going to be assigned here. But we don't want to do that. What we want to do is pass in element ID. And the other thing that we want to do is we actually want to cast that. So we're going to say as HTML canvas element. And what casting is it's taking a variable of one type and converting it to another type that it's closely related to. And I'm going to get a little bit more into object inheritance and casting in the future, so just sort of take this at face value for right now. But if we inspect element ID, or get element by ID, you'll note that it returns a generic HTML element. And an HTML canvas element is an HTML element, but it's a specialized one. So just take that at face value for right now. We're just going to create or cast this rather to a HTML canvas element. Okay, and otherwise, if element ID is undefined, we are going to say else canvas equals document.createElement. And you'll note here that this has all sorts of options. So it expects a string as the type of element. So in this case, we're actually going to say canvas. And you'll note also that this returns a HTML element as well, because it doesn't actually know ahead of time what type of element is going to be replaced. This method says, okay, you're asking for a canvas element, I'm going to create that and return it to you, but I'm going to return it to you as an HTML element. So again, we're going to cast that to as HTML canvas element. And there we go. So whether or not you pass an element ID, we have a canvas element at this point. Now, one thing that we should probably do is in this block of code right here, we should probably also check to make sure that canvas is not undefined. So if canvas triple equals undefined, which is what this method, this getElementById, returns if it doesn't find an element with that ID that we passed in, then we are going to throw a new error, and we're going to say, pass that a message, let's say cannot find an element, a canvas element actually, named, and we're going to append element ID. Okay? And what this is going to do is whenever you throw an error like this, it stops the execution of the application completely. So us not having a canvas that's found, that's a fatal error. That's an error. Our application can't continue. And so we should throw an error letting us know that this has occurred so that we can debug it. It's always a good idea to do error checking like this, especially with publicly facing code, to avoid a problem that might be harder to find further down the stream. So the quicker you can catch an error and just throw an error or throw a warning or what have you, the easier it makes to debug it down the road. So the next thing I want to do is finally, we want to get to creating our GL, WebGL rendering context here. So the next thing we're going to do is we're going to set GL equal to canvas.getContext. And getContext is something that is specific to the HTML canvas element. And it has 3 overloads that are available. So there is a context ID of 2D, which uses the HTML5 2D canvas API. That's not actually the one we're going to be using. The next one is WebGL, or experimental WebGL. So when WebGL first came out, most browsers that supported it used this experimental tag because it wasn't actually official yet. They were still sort of working on it. And now I think the only one that still uses this might be Edge. I'm not 100% sure about that though. So WebGL in most cases is actually going to do it for us. So the third option, by the way, is a string of a different type of context that maybe TypeScript doesn't know about. WebGL 2 is an example of that, but we're not using WebGL 2, we're just using standard WebGL. So WebGL in a string, and that's it. So that's all we need to do to actually get our rendering context. However, we need to check to make sure that we actually obtained a WebGL rendering context, because if the browser that is being used is not compatible with WebGL, then this will return undefined. So we need to say if GL triple equals undefined. Then again, we throw a new error, and we'll say unable to initialize WebGL. And that's it. That stops the application. We can't continue. Okay? And that should be pretty much all we need to do at the moment. Oh, I did forget one thing actually. So up here, we've created an element, but we haven't actually attached it to the page, which is going to be a problem. So if we're going about creating the element dynamically, we will actually need to call document.body.append_child. And this takes in a node, which is basically any HTML node, and we're just going to pass canvas. Okay? And that really should do it for what we need as far as the initialization of WebGL. Now, we might want this canvas later on. In fact, we are going to want this canvas instance later on. So right now we've actually declared this as a local variable. And we could put the canvas up here. And in fact, there is a reference to the canvas here, but I actually want to return this instance of it. So I'm actually going to change the return type of this initialize method to HTML canvas element. And I'm going to return canvas. So that way the method that calls it automatically gets a reference to the element that's created within. Okay, and like we talked about before, let's go ahead and comment this. So, responsible for setting up a WebGL rendering context. And our initialize method. Note something that's really powerful here, by the way. Visual Studio actually picked up by me typing this sequence of characters here that this is a method. And it picked up the name of the parameter as well. So it sort of scaffolded for us a nice little comment here that we can use. So what we're going to say is initializes WebGL, potentially using the ID of canvas with an assigned ID matching the provided if it is defined, and the ID of the element to search for. And this comment will be very useful to us in just a moment. But before I move out of this file, I just also want to comment our globally exported variable here, which is our GL. And we're just going to say the WebGL rendering context. And we're going to be using this all over the place, so it's a very convenient place to have this. So if we cut back to the engine, we have WebGL utilities that initialize, but we're not actually keeping what it's passing back to us. So The next thing we need to do in the engine is we actually need to create a new private variable, and we're going to call this canvas. It's going to be of type HTML canvas element, and we're going to say this.canvas equals glutilities.initialize, and I'm going to format the document by pressing Control-KD. I always get in the habit of formatting my document all the time. I hit it almost as often as Control-S to save it, simply because it keeps things nice and lined up and it makes it a lot easier to read. So anyway, we've got our canvas set up here. We're initializing WebGL. So the next thing that we need to do is handle our loop. So what I'm actually going to do is I'm going to remove this code here with the count and the document title being updated, because updating the document in a tight loop like that is very slow, and we don't want to do that anymore. It was just to sort of prove the point that the loop worked. So we know the loop works. So what we're actually going to do now is set this up to render a frame to our WebGL canvas. We're going to render to it once per frame. Before we actually kick off our loop, we want to set up a couple of things in WebGL that we're going to need to have set before we actually continue. So remember that we have our global variable called GL. So you'll note that we have that here, WebGL rendering context. And we're going to say GL.clearColor. Okay, so what clear color is for is it actually defines what color the screen is going to be sort of cleared to or reset to every frame before we actually draw anything on it. So what we're actually going to do here is we're going to set this to 0, 0, 0, 1. And what this actually is each one of these colors is represented by a value from 0 to 1. So if we were to say for the red channel 1, this color is actually going to be bright red on the screen. If we change the second one, which is green, to 1, then it's going to be bright green. And the third one, of course, would be blue. And any combination of these things will create colors in between that. So I'm not really going to go into a lot of detail there, but anybody that's sort of played with a photo application or Adobe Photoshop or something like that, typically that scale is on like a 1 to or maybe I think it's 0 to 255. In this case, it's 0 to 1. And alpha we always want to be 1. We don't want it to be transparent at all, and alpha is transparency. So by putting a 1 here, we're saying we don't want our canvas to be cleared to a transparent color. So what we're effectively saying here is, since we're putting no red, no green, no blue, we're saying clear the screen to black. And I'm actually going to wind up changing this in a little bit, but for right now, we'll clear the screen to black, and you'll see that here in a moment. So the first thing that we have to do inside of our loop is we actually have to say gl.clear. And this is asking for a mask or a number. And this is a pattern that sort of comes up in WebGL a lot, and the only way that you're really going to know what to use here is by researching and looking up tutorials and looking at the WebGL specification to figure out what should be passed where and what's valid. In this case, I happen to know that we want GL.color buffer bit. And what this is basically saying is we want to clear the color buffer of the screen. So the color buffer is basically what gets written to before you actually present an image to the screen. So what we're saying here is every time we clear the screen, we want to include that color buffer, which ultimately defines the pixels that get drawn to the screen's color. We want to clear that out every single time. If you don't do this, you're actually going to have one frame drawn on top of the next, on top of the next, on top of the next, and it's going to be a really weird and disconcerting effect. So we have to clear the screen every single time, and the most basic way to do that is to set the gl.color_buffer bit to be cleared. So with that, I'm going to go ahead and build this so that we can see an example of this running. I'll run it, and Control F5. And if we look here, we've got our canvas element. Oh, I left the old one on there. I was wondering why that was shifted over. Hold on one moment. We go back into the body and just remove that. I just want an empty body. Okay, let's run this again. And now we have a black screen here. So WebGL is actually initialized. It's running. It doesn't do much at the moment, but this black screen tells us that what we're doing is actually correct and WebGL is properly initialized. And you'll note that it doesn't fill the screen. It's sort of going with its default size, and those are all things that we're going to fix. And it's also got a little bit of spacing here, which we eventually want to get rid of. So what I'm going to do is I'm actually going to go ahead and end this video right here because this is a good place to stop, and we'll fix some of those things in the next video. So thank you guys so much for watching. I hope you enjoyed this tutorial. I hope you learned. Give me some feedback on what you guys think, and I will see you guys next time.